Welcome to the July meeting. And here's a nice little video on Hubble. Start us off. So always good to have some Hubble stuff, get you in the astronomy mood. So that they're still celebrating their 30 years in space, which is absolutely remarkable. But this is the 15th of July, our program meeting, and I welcome you all. And can you give me the next slide? Okay, so we maintain a calendar of events, although many of our events have been canceled due to COVID-19, our in-person events. But to keep up to date of what is going on and what events might be canceled, I would point you to our online calendar. You can find that at SDAA.org, San Diego Astronomy Association, and you can just type SDAA into Google, and we are the first thing that comes up in a Google search. So you can go there, check out our calendar. It has all of the meetings, including these meetings, are located on the calendar, as well as what would in our normal times be our outreach events of star parties and events throughout the county. Also, you can stay in touch by looking at our Facebook, Twitter, or Instagram accounts. You can go subscribe to those. They would put out a really nice announcement for this event on Instagram. Jeff Lynn did a spectacular job doing that, of course, and we put the links to these items up on our webpage. Jeff Stevens helps maintain our webpage for us and does all that work, so thank you, Jeff. And then I wanted to mention that we have, for those of you who may be new and don't have a telescope, if you're a member of the club, we have a telescope loaner program. And so you can go to our webpage, SDAA.org, and go to the Loaner Scope link and contact Ed Rumsey, who's our lead. So the club maintains a number of scopes that will lend out free of cost to members, and they can try them out, see what they like about them, what they don't like about them. And it's a great way to get into astronomy without having to dive in with large expenses of money before you know what you like. And then the next thing I want to bring up, and Dave could put up the link for that, which is our newsletter. And that's, and so you can see in the chat right there is the link to our newsletter. So you can just copy and paste that, and then just boom, you can go right to the newsletter. And there's a lot of really great material in there. We also try to put in information about what's going on in our events and events that we have to cancel or reschedule. There's great articles in there, including this month in the July version of the newsletter. There's information on online courses and talks that you can listen to for Mount Palomar or the AAVSO, which is, I think, the American Association of Variable Star Observers. So if you're into variable stars or exoplanets, there's all kinds of interesting content in there, and you can go take a look at that. So I would encourage you all to do that. So let's move on to our next chart. So we have a merchandise store. So if you want a nice hat or a sweatshirt or some other items, we have SDAA monogrammed items. And I understand we have a, and so you can just see, just popped up in the chat was the link directly to that store. So you could either go to SDAA.org and find the link on our webpage, which it is shown, or it's right there, and you can just copy paste that into your browser and go take a look now. But we are going to have a sale on items, and I will just not say any more than that. But so come take a look at what kind of interesting stuff, and you can be a supporter of the club by buying some of our merchandise. And now on to the next chart. And we have another video for you. This one on the Artemis spacesuit, which is the trip to the moon, or NASA's mission to the moon.
Watching Apollo footage of astronauts doing geology on the surface of the moon is a really great way to think about preparing for Artemis, for putting people on the lunar surface once again. We learn a lot in how they did science operations on the moon and what it's like to work on the moon. You see them doing geology. You see them taking rock samples, putting in a drive tube to take a core sample. You see them bouncing along the surface of the moon on the lunar rover that they used in Apollo 15 through 17. So it's a great way to help drive technology development for the next generation of spacesuits and geology sampling tools.
There's these facilities that help us train like we are on the lunar surface. You know, these 1.6G offload systems or putting people in the aquatic environment are great ways to train the mobility. Right? Like, what can you do and how different does it feel to be in 1.6G and do these tasks?
We've been training astronauts in geology and geoscience for decades now. The Apollo astronauts had literally hundreds of hours of training in geology before they flew to the moon. It's often said that the Apollo astronauts had the equivalent of a master's degree in geology by the time they flew to the moon. In the intervening decades since Apollo, we've been training astronauts who fly to the International Space Station because when they're on the ISS, they spend time observing the Earth, looking out the window, taking pictures of what they see on the Earth's surface. Now that we're looking at putting astronauts on the surface of the moon, we also take them into the field. We take them to field sites here on Earth that resemble field sites that we expect them to see on the moon.
That's the reason why we take them out into places that are unique like volcanic landscapes or places that are analogous to the lunar surface to train them on the scale and fidelity of science that you just can't recreate in these facilities.
And so by combining this classroom and field training, we're able to prep them for fundamentals of geology, the major driving lunar science questions that we have that we hope to address with the Artemis program, and teaching them how to do fieldwork in relevant analog environments.
For just science aspects of developing new spacesuits, can it get you to where you need to go? And then once you get there, can you do the cool science that you need to do? And so that's, can you move effectively and efficiently in the suit to be able to collect the samples or use the tools or the instruments? For the visibility, it's like, can you make the necessary observations that you need to? Or does the suit have the lights on it that it needs to illuminate the surface and make the observations you need to? The lunar South Pole holds tremendous resources that are going to allow us to continue to explore. This is a place that we've never been before. There's so much to be learned from getting boots on the ground and exploring a unique place that challenges us as humans and also helps us develop technologies that make our everyday life that much better.
We think there might be volatiles present at the South Pole. By using these volatiles, we'll be able to do things like create drinking water, create rocket fuel to launch astronauts back to Earth. And so by harnessing the power of the land, we'll be able to help astronauts establish that long-term sustainable presence.
Okay, I think we are adjusting the video at the moment.
That we hope to address with the Artemis program, and teaching them how to do fieldwork in relevant analog environments.
For just science aspects of developing new spacesuits, can it get you to where you need to go? And then once you get there, can you do the cool science that you need to do? And so that's, can you move effectively and efficiently in the suit to be able to collect the samples or use the tools or the instruments? For the visibility, it's like, can you make the necessary observations that you need to? Or does the suit have the lights on it that it needs to illuminate the surface and make the observations you need to? The lunar South Pole holds tremendous resources that are going to allow us to continue to explore. This is a place that we've never been before. There's so much to be learned from getting boots on the ground and exploring a unique place that challenges us as humans and also helps us develop technologies that make our everyday life that much better.
We think there might be volatiles present at the South Pole. By using these volatiles, we'll be able to do things like create drinking water, create rocket fuel to launch astronauts back to Earth. And so by harnessing the power of the land, we'll be able to help astronauts establish that long-term sustainable presence.
It's human nature to explore. Pushing our boundaries and exploring our universe is, I think, just one of those things that's just stuck in our human nature, and that we need to do it in order to understand the world around us, including our Earth and our solar system.
So that was kind of a little look forward, the kind of thing that NASA is going to be doing and is currently doing, which is getting ready for its return to the moon, which is the program they call the Artemis program. And then eventually it's supposed to go to Mars. But new suits is spacesuits is kind of a thing that doesn't always get the big flashy discussions, but it can matter a great deal. And so I thought this was kind of an interesting topic to give you a little bit of information on. So next chart. So another nice Hubble picture. They're particularly proud of this one, so I'm going to walk you through it here.
The Hubble Space Telescope has given us an incredible image for its 30th birthday. This image reveals a beautiful nursery for new stars in a nearby satellite galaxy to our own Milky Way. The bright, newly formed stars in the middle of this image are at least 10 times more massive than our Sun. Powerful radiation from these stars is causing the surrounding gas to glow in stunning colors. The blue indicates oxygen gas heated to nearly 20,000 degrees Fahrenheit. The red indicates the presence of nitrogen and hydrogen. Those massive stars are also driving powerful winds of charged particles which are sculpting out the bubble and ridge structures we can see across the nebula. The blue nebula at the lower left of the image is actually material ejected from a single huge star in the center. That star is 200,000 times brighter than our Sun. The whole region shows how dynamic our universe is, with stars continuing to form and affect their surroundings, and it's Hubble's exquisite vision from its orbit above Earth's atmosphere that gives us the ability to get a clear glimpse of this kind of incredible beauty and activity. The Hubble Space Telescope has changed the way we think of space and our place in the universe. Hubble has refined our understanding of the age of the universe and its rate of expansion, and through its deep fields it has peered across billions of light years to reveal ancient adolescent galaxies we can compare with our own Milky Way. It has shown us the telltale effects of mysterious dark energy and dark matter, and it has given us a front row seat to these beautiful interstellar clouds and nebulas where new stars and their surrounding disks of dust and planets continue to form. Hubble is in excellent technical health and is expected to continue its exploration of the universe for quite a few years to come. Multiple astronaut missions to service the Hubble Space Telescope over the years have kept Hubble at the forefront of capability. With each servicing mission, astronauts repaired or replaced instrumentation, keeping Hubble better than ever before. The final servicing mission in 2009 was extremely successful, so that even today, Hubble is more scientifically powerful and productive than ever before. You can find out more about the Hubble Space Telescope at the website nasa.gov/Hubble and on social media at NASA Hubble.
So that was from the Hubble Senior Project Scientist, Jennifer Weichman. And I think that's in one of the Magellanic Clouds. She didn't say, and the text under the video attached with it didn't actually have a clear statement of where it was, but given the amount of detail, I think that's probably where it is. So that's really cool. And now I have, for my next video, I've discovered there's a little hobby group out on the internet that takes 16 millimeter Apollo and older video and digitizes it, does frame interpolation, color adjustment, and makes kind of a modern looking video out of what would be, much lower quality videos. So, Dave, if you can start this one. This is the one taken.
12 frames a second coming up. You got it.
Okay.
Okay, you're looking right at Cinco and Tony. We doesn't feel like we're climbing, but we've been climbing for quite a while here. I just looked at the pitch meter, and it was pegged out a minute ago.
Wow.
We're climbing up about a 10-degree slope now.
Okay.
And let's see, 6 was at 000 at, Charlie, what should we be heading for? Those craters up there. Oh, don't tell me that. Okay, see that one? It's sort of a funny shape, looks like it's got a breach in the southeast side at 12 o'clock? Yeah. That's it. The one at 12 o'clock, huh? Yeah. Okay. Well, Houston, now that we get up to up Stone Mountain, my assessment is it's not any worse than what we've been driving down. I think this is one of our benches here, John. I think it is, huh? Yeah, we're at 3.3, and 5 should be at 3.3. And, okay, Tony, we're on a flat area now at 3.55 at 3.3. And I think it apparently is a bench. We're passing Station 5, a little to the east.
Okay, glad you can recognize it there. That's great.
And it's, I'll tell you, it's just as blocky here. The block population is up again to about 40 to 50%.
Okay, you might look for a fresh crater that would punch through that array material into Descartes for Station 5 when you come back.
No, we got lots of... Okay, most of the craters here are... there's another split one, but... Look at old South Ray, Charlie. That's beautiful. Just spectacular. I can't believe it. And there's Baby Ray, John. See it? Yeah, you can see it. It's got black sides to it. Okay, here's a crater, Tony. Remind us, at 354 at 3.4, that's about 15 meters across and about 5 meters deep, and I bet you it punched through. Oh, man.
Okay, we'll keep that in mind.
And that should be a good enough for... And that should be a good Station 5.
Okay.
Man, we are really going up a hill, I'll tell you.
How about the traction? You slipping at all?
That's the only one I see, I reckon. Okay, see, there seems to, over here by this oblong one, which I think is 5E, John, we go up a steep slope, but then it seems to level out right up on top. Yeah. Okay? Yeah. Look at that bench in Crown. I know it. No, we can't see Crown now. What is that thing with a V in it? That's 5E. The one with a V in it? Yeah. Let's go sample it. Okay, that's what I was thinking. See, it seems to be it's a steep slope going up to it, but it looks like a bench or a little ridge on top. Yep. Okay, we're at 354 at 3.6. And you ought to see that Baby Ray, Tony. It's got a real good raised rim. You can see some good, it's got lots of blocks around it that are hard to estimate the size. And we're going up a steep, steep slope, John. I'll tell you.
We believe you, Charlie.
You are not. And it's got black streaks coming out of it. Okay, our amps are now up to 60. Oh, wait a minute, that's volts. Yeah, Charlie. This is going to be spectacular. I can see wreck and trap and orange juice. Golly. There's a little bench on up there, a little bit more, John. Yeah, we're getting up on a bench right now. And boy, this is going to be such a spectacular view, you can't believe it. Okay, we're at 5, Tony. We feel at 3.7 at 355. See it anywhere, Charlie? What? 5? Yeah, this is it. Here's the one. There's one, and the big one is just to the left over there with the V in it.
Charlie, you're probably at one of the lower Syncos, not D or E. You should have something like 4.0.
Okay, we'll go. Okay, we'll go on up. A little easier driving uphill and down.
And you're well ahead on the timeline. You've been making good time.
Tony, I can see into, Charlie, let's go up here to this big blocking crater. Man, that's really good. Where's that? Right up there. That's Crown. Don't want to go up to there? Yeah, that's fine with me.
So the top speed here is like 8 to 10 miles an hour, and you've all experienced 10 miles an hour in your car, and it feels most often like you're just crawling along. But in the moon, of course, you're going over bumpy surface, and the gravity is much lower, so you tend to bounce more. And so I thought this was fascinating also for a number of reasons, like it's not like their speech is not rehearsed. It's not like you're actually hearing people really interacting the way they do, not guarded. They're not going through like a speech or anything like that they've rehearsed. And it just gives you kind of the feeling that you're there, that you're like looking over the shoulder of one of the astronauts on the rover, the car they drove around on the moon, and getting a little feel for yourself of what that would be like. I thought that was really kind of cool. And the fact that they had taken, I think it was 16 frames a second and turned it into 30 frame video and made nice quality video out of it. It wasn't like a super exciting part, like, stepping on the moon for the first time, but it was more kind of like when you go back to the moon and you're actually going to be there. If you went there, it would be kind of more like what the experience would be like. At least that's what I thought of it like. So, all right, Dave, if you can give us the next little video, which is also from the same group of people taking a
coming up
low
on pitch
frame
over
rate in
64, okay? We have LPD. LPD. Coming right. 40. 5,000 feet. 39. 39. 38. 39. 4,000 feet. 40. 41. 45. 47. 52. 3,000 feet. 52. 52. 51. 50. 47. 47. 2,000 feet. 42. Okay, got a good spot. Good. 42. 43. 1,500 feet.
Falcon Houston, you go for landing.
45. Fudge, go for landing. 44. 45. 1,000 feet. 45. 900. 45. 800. 45. 700. 46. 600. 48. 500. 49. Minus 17. Minus 15. 400 and minus 14. Yep, P66. Okay. 300 feet. Minus 11. Minus 11. 250. Minus 11. 9% fuel. 200. Minus 11. 150. Minus 7. Minus 6. 120 feet. Minus 6. Okay, I've got some dust. Minus 5. 100 feet at 5. 9% fuel. Minus 5. 80 at 5. Minus 3. 60 at 3. 50 at 3. Cross pointers look good. 40 at 3. 33. 25. 2. 7% fuel. 20 at 1. 15 at 1. Minus 1. Minus 1. 6% fuel. 10 feet, minus 1. 8 feet, minus 1. Contact. Okay, Houston, the Falcon is on the plane at Hadley.
Roger, Roger, Falcon.
No denying that. We had contact.
That was a jubilant Dave Scott reporting Apollo 15 on the plane at Hadley.
Okay, ECS looks good. Okay. Hang radars open. He looks steady. Okay, did you get the landing radar open? Yep. Okay. Standing by for T1. Roger.
Just stand by.
It looks good on board.
Falcon Houston, your stay T1.
Roger, stay for T1. Hey.
So I thought this was really cool that they made 10 of these landers, and they were going to practice with 3, and 2 in low Earth orbit. So they would just launch them up around the Earth and practice with them. And then 1 they flew all the way to the moon to practice with, but didn't land. It was just a practice. And then there were supposed to be 7 that they took and actually landed with. And it turned out one of which, Apollo 13, because of the catastrophe explosion on the way to the moon, they used the LEM as a lifeboat on the way and just skipped the moon landing. So 6 of them ended up landing on the moon. I thought that was just so cool to kind of get the feel of what it would be like going down, and that shouting out how much fuel was left in the fuel tanks. And when he got to 6%, I'm thinking, wow, that's kind of cutting it a little close. So you wouldn't want that to hit 0. So, okay. And then next. All right, so I didn't get all the information on this slide that I wanted to. So one of the things I like to do is we have a lot of really capable professionals or amateur professionals who take some spectacular imagery with their home telescopes or out at our TDS club site, which is located, for those of you who don't know, the Astronomy Club owns a dark site out basically the 8 freeway about half the way to Arizona, so far from the bright lights of San Diego, where you can get great imagery. And we have a number of telescopes there and pads for people to set up telescopes. And you can learn more about the TDS website or TDS dark site on our website, SDAA.org. So there's information on how to get there and all kinds of cool stuff. And then this is actually an image taken by one of our club members, Carl Weber, of the Dumbbell Nebula, which is up now at this time of year. It's actually quite visible. But this is a long exposure, so Carl's a very dedicated person, since taken with oxygen, glowing, which is a green color, and hydrogen alpha, which is in the red part of the spectrum, and he has over 13 hours of exposure to get this image. So I like to kind of give a little place where people can show their work, because, you know, as much as they may enjoy the whole process of taking the picture and working with the telescope and processing the imagery of the telescope, it's kind of nice to show it off to other people. In addition to doing it in these meetings, if you go to our website, SDAA.org, we have a link to what's it called? There's a place that we show a gallery of our pictures. So you can post your own pictures up there, share them, show them off to anyone that goes to our website. So
Yeah, that's a Flickr site, Steve.
Thank you. That was, I was trying to remember, what's the name of that place? Thank you, Dave. Yeah. So that's just one of the cool things, that people like to do is they take pictures and, you put so much effort into it, getting your scope all set up and perfectly aligned and functioning wonderfully. And then you take these very long pictures because 13 hours at the scope, that's multiple days of spread over multiple days to get that much time. And then being able to combine the imagery and do all the kinds of processing. And by the way, that type of detailed software and everything used to process on images is one of the topics that's discussed at our AISIG meeting. So we have a meeting that kind of specializes in camera related and scope hardware related stuff that is led by Scott Dixon, and that occurs 1 week from tonight. So please come and attend that meeting. And so if you will then take me forward 2 slides, I guess it is now. There we go. So now this is another image from Carl Weber of the Trifid Nebula, but this one is something special. So our TDS website, or TDS dark site, has a telescope where we also collect imagery, and so we do it in kind of what you might consider the raw form, where it would have, in this case, this is luminance, which is the brightness, and then collected just the red light and just the green light and just the blue light. And then we have this data, and it's calibration data to correct for imperfections in the camera and vignetting and things like that in the hardware. And you can get this data as a member of our club, and you can then process it at home. So if you're one of those kind of people that likes the whole software side, and you like astronomy, but maybe you're not the super enthusiastic about the hardware and setting up the telescope and spending that time out in the cold weather or the hot weather, depending upon the time of year, taking those pictures, but you kind of like the idea of, building up the pictures and making these gorgeous images that you can make choices on for, what kind of processing you do. You can get, we have a repository of this kind of data, and if you will contact Dave Wood, and I should have actually gotten a link for you, Dave, but he has access to this archive that we maintain of this data, and you can get access to it to then process on your home computer, and make gorgeous images yourself out of essentially the output of what comes out of these cameras. So something to think about, different kinds of things. Some people like what I call visual astronomy, looking through telescopes and seeing things with their eyes. Some people like cameras and the hardware, and some people may gravitate towards the software and the aesthetics, and some people may like all of that. And so this gives you kind of choices of the kind of thing you might choose to do. And this was done with PixInsight, which is a very popular software image processing tool used, which is one of the relatively common topics that pops up in the AISIG group meetings, which are held on the 4th Wednesday of the month. This meeting's always on the 3rd Wednesday of the month. And so that's all I wanted to say about that. If you'll give me the next chart. So in the next chart is our digital door prize. So many of you may already have what is called the planetarium program, where it's a piece of software where you go look up what's in the sky and tonight or tomorrow night, and you can set it for any time, and you can look in any part of the sky, and you can zoom in and zoom out. It's like being in a planetarium where they take you on a walk through the sky. Well, there's a free online, so you don't need any software, there's nothing to download. You just, and if Dave will put the link in the chat for this. There it is. So you can copy that link now, which is the last thing in the chat, it takes you to this website that is a web tool. So you don't download anything. There's no plug-in. You don't need an account or give them your email or anything. But it's an online version of a piece of software called Stellarium, which is a planetarium program, and you can zoom in and see what's up in the sky. So it helps you. A lot of astronomers use this to help them plan. In the evening, they'll think, what do I want to go take pictures of? Well, let's go see what's up right now and where is it in the sky kind of thing. So here's a free online web-based tool that you can use to go look at any time, or you can even do it in the reverse. Sometimes I've gone outside and gone, oh, look at that bright object in the sky. It looks like a planet. What planet is that? Or is it just a bright star I'm confusing it for? And Stellarium also has a free downloadable version that's more capable than the web version. And you can, I must say that actually one time I was outside and I was looking at this thing flying across the sky at high speed, and I walked back in and looked at my Stellarium program, and it told me it was the International Space Station. So it's really kind of cool. You can see many of these, the full version, which is also free, has satellites and stuff like that in it, but you can zoom way in and see what the planets look like, or these nebulas. You can zoom in on them and get a kind of a feel of, is that the kind of thing I might want to take a picture of if you're into pictures, or if you just want to peruse the sky and see what's up there. It's that kind of free online tool for that. So this is our digital door prize for this evening. Please feel free to take home one for each and every one of you.